Hello my dear young friends and beloved students. Welcome back to Sea Level Physics after a long gap. My name is Srinivas. Today I am going to discuss projectile on an inclined plane, which is very important as far as neat and advanced are concerned. Okay. Now let us see projectile on an inclined plane. In first case, projection of the inclined plane. See here it is horizontal, right? What is the angle made by inclined plane with horizontal? Theta. So theta is the angle made by inclined plane with the horizontal, right? So I am taking the xy plane such that x-axis is fixed to inclined plane and y-axis is normal to inclined plane, right? So this one xy plane, in which body is going to move. Okay. Now here see, one body of mass m is projected with some initial velocity u from this point such that making an angle alpha with the x-axis as shown, right? Now what is the angle made by initial velocity with the inclined plane? Alpha. At the same time, angle made by initial velocity with the horizontal, that is alpha plus theta, right? See here, angles, both angles are in anti-clockwise sense, right? See here, this is what theta, angle made by inclined plane with the horizontal. This is what alpha, angle made by initial velocity with the inclined plane, otherwise x-axis, right? Now, at the same time, what is the total angle made by initial velocity with the horizontal, that is alpha plus theta, alpha plus theta, am I right? Now, when our body is projected as shown here, this is subjected to gravity. What is the direction of gravity? Vertically downwards, vertically downwards, right? So because of gravity, even the body is projected along straight line, it will not go along straight line. Every instant it is deviated from straight line path and going to take one parabolic path as shown in figure, am I right? That is due to effect of gravity. So due to combined effect of velocity and gravity, it takes parabolic path as shown, right? So what is the point of projection? Let it go. What is the highest point here? A. A is the highest point. What is the point at which it strikes on the inclined plane? Means that is P. Am I right? So I took 3 points O, A and B as shown in its path. Am I right? So A is the point of projection, A is the highest point and B is the point on the inclined plane at which body strikes. Okay. Now, as initial velocity makes an angle alpha with x-axis or inclined plane, it can be resolved into two components. See, this one xy plane, xy plane. Suppose here I am taking this one x-axis, there it is x dash, there it is y, there it is y dash. So positive x, negative x, positive y, negative y. So that is what sign convention, which we are going to follow here, right? So here initial velocity inclined in this xy plane such that making an angle alpha with the x-axis. So it can be resolved into two components. One is initial velocity along x-axis, that is what ux is u cos alpha, u cos alpha. Ux means u cos alpha, right? Uy means along y-axis, that is uy equal to u sin alpha. These are nothing but components of initial velocity. One is ux, that is u cos alpha, another one is uy, that is u sin alpha. So u cos alpha is along x-axis, that is up the inclined plane. U sin alpha is normal to the inclined plane, that is towards positive axis. So this is what positive x-axis. So u cos alpha is positive. See the direction of u cos alpha along positive x-axis. Similarly, see the direction of u sin alpha, that is towards positive y-axis. So both components are positive here. Am I right? Now next I am going to draw G. See here, this is what inclined plane once again. Somewhere here G downwards. This is what angle made by inclined plane with the horizontal, right? Now I am going to split this G bar or vector G bar into two components. One is parallel to inclined plane, another one is perpendicular to inclined plane. See here, this one perpendicular, this one parallel. Okay. Now this one angle 90 degrees. Here theta, here 90, here 90 minus theta. Right? Here 90 minus theta. Again, these two are perpendicular to each other. So if it is 90 minus theta, definitely this is theta. Am I right? So theta 90, 90 minus theta, here it is 90 minus theta, here it is theta. Am I right? So G can be resolved into two components as it is making an angle theta with the normal drawn to the incline. Am I right? So the component along normal drawn to the inclined plane is, that is G cos theta. Down the inclined plane is G sin theta. G sin theta. Okay. Why? Because here G bar is like this. G bar. Right? So here what is the angle made by G with the negative axis? That is theta. Theta. Am I right? So G acting in third quadrant. Moreover, making an angle theta with y dash. So therefore, it finds two components. One is towards negative y axis, another one is towards negative x axis. See, what is the direction here? X dash. So this is what Ax equal to minus G sin theta. Ax equal to minus G sin theta. Why it is negative sign means, see this one negative x axis. So this G finds G sin theta, component G sin theta along negative x axis. So acceleration along negative x axis, that is minus G sin theta. Similarly, the same G finds one more component along negative y axis like this. So this is what Ay equal to again minus G cos theta as per this sign convention. Okay. X dash means positive x, negative x, positive y, negative y. So G sin theta negative, G cos theta also negative. So both Ax and Ay are negative here. Right? So that's how one can find components of U as well as components of G. Okay. How it possible means by taking x-axis along the inclined plane and y-axis normal to the inclined plane. So now I am going to tilt this diagram, entire diagram. Otherwise, I am going to tilt xy plane into usual orientation like this. What is the usual orientation here? Like this. See, this is what x-axis. This is what y-axis. Now same diagram can be written as like this. So this is what initial velocity U. This is what point of projection O. Highest point A. This is what point on the inclined plane at which body is going to strike. That is point B. Point B. Am I right? So xy plane is tilted after taking all these components. After taking all these components, that is U cos alpha along positive x, U sin alpha along positive y, G sin theta along that is down the inclined plane, and G cos theta normal to the inclined plane like that. Alright. Now after taking all these components, now I am going to tilt xy plane like this into usual orientation. Right. Now what is the component of G along negative y axis? That is G cos theta. So Ay equal to minus G cos theta. What is component of G along x-axis? That is negative x-axis. This is what positive x, negative x. Negative x towards negative x. What is the component of acceleration due to gravity? That is minus G sin. So Ax equal to minus G sin theta like this. Okay. So Ay minus G cos theta, Ax minus G sin. Moreover, what about Ux? That is towards positive x-axis. So this is what Ux, that is U cos alpha. It is alpha, right? What is the angle made by U bar with x-axis alpha, right? One more component, that is Uy. Uy is towards positive axis. So Uy equal to U sin alpha like this. So these two diagrams are both one and the same. What makes the difference here? Simply this xy plane is tilted in clockwise, right, as shown below. Okay, so both are one and the same, right? Now what is the time taken by the projectile to reach B? after projection from O. That's what time of flight, right? So here it is, body is projected like this and body is going to strike point B on the inclined plane. Now what is the time elapsed here? Time equal to T equal to capital T. So time taken by the projectile to go from O to B is time of flight. Alright. So here it is, O to B means somewhere here, O to B like this. So what is the time here? T equal to capital T. T equal to capital T. Right? What is the vertical displacement covered or vertical distance covered by the projectile from O to A, that is during ascent. During ascent means your body is projected at point O, but it takes parabolic path like this, O to A and again from A to B. So from O to A, that is during ascent, what is the displacement covered by the body? That is plus h, O to A, right? From A to B, that is during descent, the same body covers a vertical displacement of minus h. Now what is the total displacement along vertical in entire flight means plus h minus h, that is 0. So in entire flight it covers plus h minus h, that is 0 vertical displacement. Now what is the total displacement or distance covered by the projectile along x-axis from O to B means, that is range. So O to B, this what distance or displacement covered by the projectile along x-axis. So x coordinate is r, range, that's what range. The total distance or displacement covered by the projectile along x-axis in the entire flight is known as range. So from here to there, that is range. So x coordinate is range. Y coordinate, what about y coordinate? Plus h minus h. In the entire flight, total vertical displacement covered becomes vanishes. Why? Because during ascent from O to A, it is plus h. During descent from A to B, that is minus h. On adding both, we will get 0. So y coordinate is 0, right? Y coordinate 0. So as you know very well, here as far as xy plane is concerned, point O as well as point B are 2 points which are at same level as far as x-axis is concerned. So during projection, what is the vertical component velocity at O? That is u sin alpha. When it strikes the incline somewhere here at point B, the same speed, it finds the same speed as body is when it is at the point O. So when it is at point O, what is the vertical component velocity? U sin alpha. When it strikes B, inclined plane at B, it finds same component of speed, that is Vy equal to u sin alpha. U sin alpha. Why? Because as far as x-axis is concerned, both O and B are at same level, right? So therefore, if Vy equal to u sin alpha, here Vy must be u sin alpha. Here what makes the difference here? Here u sin alpha is along positive axis. Here Vy, that is u sin alpha, is along negative y-axis. Okay, right? So same can be written as u Vy equal to u sin alpha. U sin alpha. Alright? Okay. What are the components for what are the coordinates for B here? R comma 0. Why? Because during ascent displacement is plus h, during descent displacement is minus h. So plus h minus h 0. So what are the coordinates for A here? This one half of the range, that is r by 2. X coordinate is r by 2 and y coordinate is plus h, right? Here at point A, what is the vertical component velocity here? Vy equal to 0. At point A, at highest point, what is the vertical component velocity? That is 0. So here also Vy equal to 0. So because of gravity, vertical component decreases and becomes 0 at highest point. So here also Vy equal to 0, right? Right? So therefore, so here Ax is minus g sin theta towards negative x-axis, Ay equal to minus g cos theta towards negative y-axis. Here Vy equal to u sin alpha towards negative y-axis, Vy equal to u sin alpha towards positive y-axis, and so on. Now I am going to derive expression for time of flight. What is the time of flight? The total time for which body remains in air is known as time of flight. So here, when body is projected from point O like this, it strikes the inclined somewhere here. Now what is the time elapsed? That itself time of flight, right? T equal to capital T, right? So how to derive expression of time of flight? Time of flight means that is time of flight. Time of flight, capital T, number 1. Parameter number 1, time of flight, capital T. So I'm going to consider V equal to U plus AT along y-axis. See here, Uy equal to U sin alpha. Here, Vy equal to U sin alpha. But here it is upwards, here it is downwards. So if I take the same expression V equal to U plus AT along y-axis, V equal to U plus AT along y-axis. So Vy equal to Uy plus Ay t. For segment entire flight, for entire motion, for entire motion, take Vy equal to Uy plus Ay. That is, Vy means, see here, this is Uy, this is Vy. Vy means towards negative axis, Uy means towards positive axis. Therefore, take with sign convention, that is minus U sin alpha. Minus U sin alpha equal to Uy means U sin alpha. U sin alpha. Plus Ay means what? What is Ay? Minus G cos theta. Minus G cos theta. Into what is the time here? That is time means capital T. Entire flight. So if I consider V equal to U plus AT along y-axis in the entire flight for entire motion. So here it is, U sin alpha becomes initial velocity, U sin alpha again becomes final velocity. But what makes the difference here? This is towards positive axis, this is towards negative axis. So that's why here it is with the negative sign. Okay. Now plus or minus G cos theta, take this side, that is G cos theta into capital T equal to U sin alpha minus U sin alpha becomes 2U sin alpha. Okay, and take into RHS, that is U sin alpha plus U sin alpha. It becomes twice U sin alpha equal to G cos theta into T. So therefore T equal to 2U sin alpha by G cos theta. G cos theta. So what is the expression for time of flight here? T equal to 2U sin alpha by G cos theta. What is U sin alpha? That is the vertical component of velocity. That is velocity along, initial velocity along y-axis. So therefore U 2Uy divided by, what is G cos theta here? G cos theta means acceleration along y-axis. Acceleration along y-axis. That is Gy 2Uy by Gy. Right? So this is what expression for time of flight. Okay. Now coming to second parameter, that is maximum height. Maximum height. Maximum height, H. What is maximum height here? After projection like this from point O, it reaches highest point A in its path. Now from the inclined plane, plus H becomes maximum height during ascent from O to A. Am I right? So here at point O, what is the vertical initial velocity? U sin alpha. At point A, what is the vertical final velocity? G. So take expression V square minus U square equal to A is to find maximum along y-axis. So V square minus U square equal to 2A is for entire motion. From O to A. From O to A, or for O to A, for the segment O to A, for O to A, right? So during ascent, take V square minus U square to A is along y-axis. Y-axis like this, right? What is Vy here? Vertical velocity at point A becomes Vy. What is Uy? Vertical velocity at point O, that is at point of projection, that is U sin alpha. So Vy means 0 minus Uy square means U square sin square alpha. U square sin square alpha. u square sine square alpha equal to 2 into ay means what is ay here? Minus g cos theta. Minus g cos theta into sy. Sy means from here to there, otherwise from here to there, that is plus h. Plus h. Right? So minus minus cancel. We left with h equal to u square sine square alpha divided by 2g cos theta. That is, if you want to generalize, u square sine square alpha, that is uy whole square. What is u sine alpha? Uy. So u sine alpha whole square, that is uy square. Uy square by 2 into what is g cos theta here? G cos theta means vertical component of acceleration, that is acceleration along y-axis. So 2 g suffix y. So this is the general expression. So time of flight t equal to 2u sin alpha by g cos theta, that is 2 uy by gy. Similarly, maximum height equal to u square sin square alpha divided by 2g cos theta, that is uy square by 2gy. Right? Okay. In case of usual oblique projectile, what is the expression? 2u sin alpha by g only, but here g cos theta. In case of usual oblique projectile, when it is projected at an angle alpha with horizontal, what is the maximum height? In that case, u square sin square alpha by 2g only, but here 2g cos theta only. Right? Like this. Suppose body is projected like that, some initial velocity such that making an angle alpha with horizontal. See here, body is projected from the level ground such that initial velocity making an angle alpha with horizontal. Then what is the at time of flight here? T equal to capital T. What is maximum height here? H. So T equal to 2u sin alpha by g only. Why? Because here what is the acceleration along y-axis here? See, along y-axis, what is the vertical component of velocity initially? That is u sin alpha 1 along y-axis. Along negative axis, what is the acceleration here? g1, right? So therefore, time of flight equal to 2u sin alpha by g only. I'm generalizing, that is 2 into u sin alpha means uy divided by g means gy. That is acceleration along y-axis. Here it is gy only, but here it is g cos theta. G cos theta. In case of maximum height here, h equal to u square sin square alpha by 2g1. That is uy square by initial velocity along y-axis square by 2 into g. G means what? G means what? Acceleration along y-axis. But here instead of g here we have only g cos theta. That's why a small modification for both t and h. That is t equal to 2u sin alpha by g cos theta. Maximum height equal to u square sin square alpha by 2g cos theta. Right? Now coming to range. How to find range? What is range here? When it is projected like this from point O onto inclined plane, it strikes on point B somewhere here. Right? Now OB becomes range. So in the entire flight, the distance covered along x-axis. See, inclined plane itself x-axis. Why? Because x-axis is fixed to plane of incline. So along x, what is the displacement or distance covered by the projectile in entire flight means OB. That itself range. Here it is x coordinate range. Right? Now coming to range. How to find range? So here we have time of flight 2u sin alpha by g cos theta. Right? Now range. How to find range here? So on keen observation diagram, we came to know that what is the angle made by initial velocity with horizontal total angle, that is theta plus alpha, otherwise alpha plus theta. Now what is the component of u bar along horizontal? U cos alpha plus theta. So making use of that point, you can find shortcut derivation for range. Shortcut derivation. Right? See here. This is what u. This is what horizontal. What is the angle made by u with horizontal? See, this is what horizontal. So alpha plus theta. Angle made by u with horizontal. Alpha plus theta. Right? Okay. Now it takes parabolic path like that. Like that. Now O, A, B like this. Otherwise here. So point O, A, B. O, A, B like this. Point O, A, B like this. O, A, B. If I join P to the horizontal like this, say this is what C. Now what is this component OB, that is R? OB equal to R. Now what is the angle here? Theta. What is the angle here? Angle made by U with inclined, that is half. Right? Half. Okay. Here it is B. Right? Now what is the time taken by the projectile to reach B from O means, that is capital T. T equal to capital T. In the same time, the projectile covers this much of distance along horizontal. This is what horizontal. This is what horizontal. Horizontal. Right? When projectile reaches B in the entire flight, during that time it covers this much of distance, that is OC, along horizontal. Now what is the time taken to cover this much of distance by the projectile means T equal to T1. So what is the component of velocity along horizontal along this way, that is U cos alpha plus theta. Why? Because here U makes an angle alpha plus theta with horizontal. So along this way, along OC, what is the velocity? U cos alpha plus theta. What is the time taken to reach C? Of course, directly body is not reaching position C, but it strikes one point B on the incline. But at the same time, when it strikes point B on the incline, it covers a distance of OC along horizontal. But the time taken is T1. So if it is R, what is the component of along OC, that is R cos theta. Distance is R cos theta. So velocity is U cos alpha plus theta, but distance is R cos theta. Right? Along horizontal, is there any acceleration? No. So acceleration along horizontal is 0. Horizontal is equal to 0. Why? Because gravity is acting vertically downwards. So there is no component for gravity along horizontal. So there is no acceleration along horizontal. So along horizontal motion is uniform. So simply take displacement equal to velocity into time. That's all. Displacement is velocity into time. So along horizontal, displacement equal to velocity into time. Why? Because motion along horizontal is uniform. There is no component for acceleration. Why? Because G is downwards. So for any vector, there is no component in a direction perpendicular to itself. So G is downwards. But here, what is the angle here? 90 degrees. So A equal to 0, since A equal to 0, since A equal to G cos 90. G cos 90 along horizontal. G is downwards, but I am going to determine its component along horizontal. Now what is the angle here? 90 degrees. G making an angle 90 with horizontal. So what is the component of G along horizontal? G cos 90. G cos 90. That is equal to G cos 90. That's why 0. Acceleration along horizontal equal to G cos 90, that is 0. So as there is no acceleration along horizontal, motion along horizontal is uniform. So that's why I am taking displacement along horizontal means along OC. Displacement equal velocity into time. Displacement means if it is R, what is the component OC, that is R cos theta. R cos theta equal to velocity along horizontal OC. What is the velocity? U cos alpha plus theta. U cos alpha plus theta into u cos alpha plus theta, u cos alpha plus theta into time. What is the time from O to C? What is the time from O to A to B? That is T. So for OC also same time, that is time of flight. That is R cos theta equal to U cos alpha plus theta into time of flight. Now itself we have derived the expression for time of flight. What is that time of flight? 2U sin alpha by G cos theta. Alright. So I'm making subject R, that is R equal to 2 into U cos alpha plus theta into U sin alpha by G cos theta into cos theta, that is G cos square theta. G cos square theta. This is what expression for range. So why it is R cos theta? OC is, why it is R cos theta means OB is R. Now what is the component along OC for R? That is R cos theta. It is R, the same distance R finds R cos theta along OC, right? So R cos theta is nothing but the component of R along OC. That is R cos theta equal to U cos alpha plus theta. Velocity along horizontal. If it is U, angle made by U with horizontal, that is alpha plus theta. That is, what is the component of U along horizontal? That is towards OC, that is U cos alpha plus theta into time of flight. So that's how one can find expressions for all the three. What are the pyramids? Time of flight, maximum height and range. Time of flight, maximum height and range. So what is expression for range here? 2 U cos alpha plus theta into U sin alpha by G cos square theta. So coming to a numerical here, that is, suppose here alpha equal to 30 degrees, theta also 30 degrees, U equal to 10 meters per second. Now what are the parameters here? Alpha equal to theta equal to 30 degrees, U equal to 10 meters per second. Find time of flight, maximum height and range. Time of flight, maximum height and range. How to find? Already we have expressions for time of flight, maximum height and range. What is the expression for time of flight here? What is the expression for time of flight? Time of flight. Time of flight. First one, number 1, capital T question mark. T equal to 2U sin alpha by G cos theta. That is 2. What is U here? 10 meters per second. That is 2 into 10 into sin alpha. That is sin 30, 1 by 2 by G, suppose 10 meters per second square. To cos theta also root 3 by 2. Root 3 by 2. So 10 cancel, 2 cancel, that is 2 by root 3 seconds. Next, number 2, maximum height. How to find maximum height? What is the expression for maximum height? That is h equal to U square sin square alpha by 2G cos theta. That is U square. What is U square? 10 square, that is 100. 100 into sin square alpha. Sin alpha means sin 30, that is 1 by 2. But here sin square alpha, that is 1 by 4. 1 by 4 divided by 2 into G means 10. For example, cos theta. Cos theta equal root 3 by 2. Root 3 by 2. Right? So 2 cancel here. 0 cancel here. 10 by 4. That is 2.5 by root 3. That is 2.5 by root 3 meters. So that's about time of flight, maximum height. Now coming to range. So what is the expression for range here? 2u cos alpha plus theta into u sin alpha by g cos square theta. Right? G cos square theta. Now see here. Coming to range. Third point range. So range equal to R equal to 2u cos alpha plus theta into u sin alpha by g cos square theta. Am I right? So third point range equal to R equal to 2 u cos alpha plus theta. U means what? 10. Velocity projection 10. Cos alpha plus theta. Alpha means 30. Theta is 30. Cos 30 plus 30. That is cos 60. Cos 60. Cos 60 into u sin alpha. U means 10. Sin alpha. Sin 30. Sin 30 divided by g cos square theta. That is cos square 30. Cos square 30. That is 10 cancel. 2 into cos 60 1 by 2 into 10 into sin 30 1 by 2 divided by cos square 30. Cos 30 means root 3 by 2. Root 3 by 2 whole square. That is 2 cancel here. 10 by 2 means 5. By root 3 by 2 whole square means 3 by 4. That is 4 5 are 20 by 3 meters. 20 by 3 meters. Okay. So that's how one can find time of flight, maximum height and range in case of body projected up the inclined plane. Right? Okay. Now one more question. Suppose in some situation, suppose here, see in this case, for example, suppose a body is projected up the inclined plane with some initial velocity u, thus that making an angle alpha with the inclined plane. Now what is the angle made by inclined plane with arch angle theta? So usual notation. So u is the velocity projection, alpha is the angle made by initial velocity with the inclined plane, and theta is the angle made by inclined plane with the arch angle. Right? Now this is what y-axis, this is what x-axis. Am I right? Suppose your body strikes the inclined plane normally. Strikes the inclined plane normally like this. Normally. In this example, body strikes the inclined plane normally. When it strikes the inclined plane normally, the net velocity is normal to the inclined plane. Right? Then we can't resolve velocity into components. Why? Because see, this is what net velocity like this. What is the component of velocity along inclined plane that is perpendicular to V? That is Vx must be 0. Vx must be 0. Why? Because as far as xy plane is concerned here, body strikes the incline normally, means net velocity is along normal. Right? That is perpendicular to inclined plane. So therefore there is no component for velocity along x-axis. That is Vx equal to 0. So Vx equal to 0. Right? It strikes normally the inclined plane somewhere here 90 degrees. X component of velocity 0 naturally. So therefore on taking V equal to u plus at, V equal to u plus at along x-axis, x like that, V equal to u plus at like that. Now what is the final velocity with which it strikes the ground along x means 0. Ux means, what is ux here? U cos alpha. So naturally this is u, here angle is alpha, therefore this vector finds u cos alpha along x-axis. So ux means u cos alpha plus ax means, what is ax? In previous case ax means ax, that is minus g sin theta, acceleration along x-axis minus g sin theta into time. Time. What is the time here? As projectile strikes the inclined plane normally, it strikes the inclined plane. So what is the time elapsed here? Entire flight. That is time of flight. Capital T. So 0 equal to u cos alpha plus or minus g sin theta into what is expressed for time of flight? 2u sin alpha by g cos theta. 2u sin alpha by g cos theta. That is g cancel here. 0 equal to u cos alpha minus sin theta by cos theta, tan theta. That is 2 is there here. 2 u sin alpha into sin theta by cos theta, tan theta. Now take this term onto LHS, that is 2u sin alpha tan theta equal to u cos alpha. That is u cancel here. Tan theta equal to 1 by 2 into cos alpha by sin alpha, that is cot alpha. Right? So what is the relation here? Tan theta equal to 1 by 2 cot alpha. Provided when body is projected up the inclined plane. Moreover, if it strikes the incline normally, then what is the relation between alpha and theta here? Tan theta equal to 1 by 2 cot alpha. Okay friends, with this I am concluding. If you really impressed with my video, please subscribe my channel, like my video, share my video and comment on my video. Thank you.